Okay, so let's start with this one on the second part of this section in the chapter. So the rate of a stream is 3 miles per hour, and if a crew rows downstream with it for a distance of 8 miles and then back again the same 8 miles, the round trip takes 5 hours. What is the rate in still water? All right, so let's kind of draw a picture of what we have. And so we know the stream is going 3 miles per hour. So when we go with the stream, if we say x is equal to still water speed, then that's going to be x plus 3. And if we go back the other way, that's going to be x minus 3. Okay. So let's write our table. Our rate times time is equal to our distance. We know it's 8 miles both directions. Now we go with the stream is going to be x plus 3. So if we say this is with and this is against, that's going to be x plus 3. Now let's call that one time. It doesn't matter. We'll say it's just t. And then when we go against, we're going to go back the other direction. That's going to be x minus 3. And now we know it's going to be 5 hours total minus how long it took here. So it's going to be 5 minus t. Okay. Now we solve for t, so basically we solve for the second column. So here we get t is equal to 8 over x plus 3. Here we get 5 minus t equals 8 over x minus 3. Now again, we already solved for t, so we just plug that in right there. And so when we do that, we're going to have 5 minus 8 over x plus 3 equals 8 over x minus 3. Now, we're going to multiply by the LCD. Well, what's the LCD? Well, that's x plus 3, x minus 3. So we'll do that here. Now, when we take that times 5, well, we're just going to get 5 times x plus 3, x minus 3. And then we'll have minus 8 times, well, the x plus 3's cancel, so we'll have x minus 3. And that equals 8 times, now the x minus 3's cancel, so we have x plus 3. Now, what is x plus 3 times x minus 3? Well, that's just x squared minus 9. So we'll take 5 times that. And that's going to be 5x squared minus 45. And then we have here a minus 8x and then plus 24 equals 8x and then plus 24. As we've kind of seen before, when you have the same thing on both sides, they cancel. So we don't have to worry about that. Now this is all positive 5x squared, so let's take 8x to the other side. And so now we have 5x squared, then minus 8 is going to be minus 16x, and then we have minus 45 after that. That's equal to 0. Now what we need to do is factor. So 5x and x. And with 45, that's 9 times 5. Usually when we have nothing that's in common, we can't have the 5 here, so that means the 9 has to be there. So does that work? 25 minus 9, that would be 16, so we need that negative, that positive. And so 5x plus 9 equals 0, and x minus 5 equals 0. So x is equal to 5, and x equals a minus 9 over 5. Well, we can't have a speed of negative for water, and so the speed in still water is this, x equals 5 miles per hour. So that's in still water. And that's really all they asked for. Now, can we find anything else? Well, yeah, we can say, okay, well, 5 plus 3 is 8 miles per hour with the stream, and it's going to be 5 minus 3, or 2 miles per hour against the current. Okay, so we got all 3 speeds, but the only one they really wanted was this one. All right, how about this one? So by going 15 miles per hour faster, a train would have required 1 hour less to travel 180 miles. How far did it go? All right, well, let's make our table. This one's just easy enough to basically write our table. So we know it's 180 and 180. So no matter which way we did it, it's 180 miles. And let's let our rate, this one here be x, and this one is going to be t, because we're just going to base it on that, because the other one's going to be faster and it's going to take less time. So this one's going to be x plus 15 because we're going that much faster. And because of that, it takes 1 hour less. So it's going to take t minus 1. Okay. Now we've got our table set up. All we have to do now is solve for that middle column again. So here we have t equals 180 over x. Here we have t minus 1 equals 180 over x plus 15. Now we've got t solved for, so we can plug that in right there, and we have 180 over x, and then we have minus 1, and that's equal to 180 over x plus 15. Now we're going to multiply by the LCD. Well, what is the LCD? Well, that's going to be x times x plus 15. We have x and x plus 15. And so we multiply times the first one. The x's cancel, so we'll have 180 times x plus 15 minus, and now we just have x times x plus 15 equals, now the x plus 15's cancel, x. Now we have to distribute and get rid of parentheses. So we have 180x, then we have plus, and then we multiply that out. We get 2700, it says. And then we have minus x squared minus 15x equals 180x. Okay. All right, we have a negative here, so we're going to have to add x squared to both sides. Here we have 180 minus 15, so we're going to 165x from both sides. And here we have subtract 2700 from both sides. So after we do all of that, what do we have? Well, we have 0 equals, now we have x squared. Now the 180 is canceled, so really we only have on the right side, we have the plus 15x. And then we have the minus 2700. Okay. Now this one we're going to have to kind of play with. So we'll have 2700. Well, that's 27 and 100. Does that work? No, it doesn't give us 15. What if we take with a 270 and 10? That doesn't work. Now let's start dividing. Let's divide that by 3. So that's going to give us 90. Multiply it by 3. That's going to give us 30. That's not there. Let's divide by 2. So it's 45. And that's going to give us 60. 60 minus 45 is 15. So there we go. And so we have x. We want plus 60 minus 45. So then we can set each of those equal to 0. And so x is equal to 45, or x, oh, let's see, that's a plus 60 equals a negative 60. That doesn't work for how fast it goes. So the train went 45 miles, it's miles per hour here, so miles per hour. And that was the speed here. Now, if we wanted to know this one, that's going to be, 45 plus 15, which is equal to the 60 miles per hour. But it only asks for the original speed, which is the 45 miles per hour. All right, so let's look at another one. What if a train, this is going to be similar, travel 5 miles an hour faster instead? It would need 1.5 hours less time to travel 150 miles. So let's look at this one. So we're going to do the same kind of thing. We're going to have our rate, our time, and our distance. Well, the distance is 150 miles for both of them. This one is t, this is x. So that's our rate, our time, that's set. Well, go 5 miles per hour faster, so x plus 5, and it's going to take 1.5 hours less, so it's going to be t minus 1.5. Now again, we're going to solve for that t. T is equal to 150 over x. Here, t minus 1.5 equals 150 over x plus 5. Now again, we've solved for t, so what we can do is we can plug that in there, and we'll have 150 over x minus 1.5, and that's equal to 150 over x plus 5. And now we'll multiply by our LCD, which is just x times x plus 5. Now, when we do that, the x's cancel on that first term, so we have 150 times x plus 5 minus, now nothing cancels, so we have 1.5 times x plus 5 equals, now the x plus 5's cancel, so we have 150x. All right, now what does that give us? Well, we have to distribute. So we have 150x plus, and that's going to be 750, and then that's going to be minus 1.5x squared, and then that's going to be a minus, and that's going to be a 7.5x. That equals 150x. So now we're going to take everything over, and I think before I do that, this one I'm going to kind of show you what you could do. Well, 150x is on both sides, and so when we take it over, now all we're taking over is all of this stuff here. And another way we could do it now is, since we know that that's equal to 0, is we can multiply everything here by a negative, and so if we rewrote this, we had negative 1.5x squared minus 7.5x plus 750 equals 0. So if we multiply by a negative 1, we get 1.5x squared plus 7.5x. And then we have minus 750 equals 0. Now, we have all these halves. So if we want to get rid of those halves, we probably would want to multiply by 2 as well, because that's not a nice whole number to try to factor. So that's going to give us 3x squared plus, and then we're going to have 15x, and we have minus, and that's going to be 1500 equals 0. All right, now we're going to factor. So that's going to be 3x and x. And now we kind of have to think about factors of 1500. So maybe we come over here. And so 3 times 5, so 30 times 50. That's going to give us 20. We need 15. Divide that one by 2 maybe, so get 25. Multiply it by 2, we get 60. That's going to give us, that will work. So if we add 60 minus 25. Yeah, let me get my calculator. I'm thinking wrong here. That's going to give me 35, but I have this factor of 3 here. I forgot to put that in there. So if we plug in 30 here, that's 90 minus 50, that's 40. That doesn't work. So then if I plug 25 here, that's 75 minus 60. Okay, so that works. 25 and 60. And I want a positive, so that one's bigger, that one's smaller. I see that if I would have divided by 3, I could have smaller numbers to work with, but that's okay. We still factored it. And so here we get x equals, if we take 60 over, divide by 3, that's going to be 20. And here, if we take it over, it's going to be a negative 25. That's out. This works. And so find the rate of the train. Well, the train was going 20 miles per hour. And this faster one was going 25 miles per hour. So if they ask for that one, we could get the second one, but they only ask for the original speed. All right, so let's do one last one. Here it has Mr. Jones visits his grandmother who lives 100 miles away on a regular basis. Recently, a new freeway has opened up, and although the freeway route is 120 miles, he can drive 20 miles per hour faster on average and take 30 minutes less time to make the trip. What is his rate on both the old route and on the freeway? All right, well, here, let's go ahead and do our rate, our time, and our distance. So originally it was 100 miles. Now it's 120 miles. Let's say he originally drove x, so his new speed is x plus 20. And it takes 30 minutes less. So let's say this was t, and 30 minutes is half an hour, so that's going to be t minus 1/2. So now we've got everything we need here, so we can solve for that t column. And so it's going to be 100 over x. And this one's going to be t minus 1/2 is 120 over x plus 20. Now again, we can plug that in because we've solved it for it here. And so we have 100 over x minus 1/2 equals 120 over x plus 20. Now, what is our LCD? Well, the LCD now is 2x times x plus 20 because we have the 2 here. So it's 2x times x plus 20. Now multiply that by first one. The x's cancel, so we'll have 2 times 100, so that's going to be 200 times x plus 20 minus, now here the 2 cancels, so we have x times x plus 20 equals, now the x plus 20's cancel, and we'll have 2 times 120, that's 240x. Okay. Now what do we have? Well, that's going to give us 200x plus 4,000 minus x squared minus 20x equals 240x. That's negative, so let's take it over here. So that's going to be plus x squared plus x squared. Now we have 200 minus 20, so that's going to be, we're going to have to subtract off 180x. And we're going to subtract off 4,000 as well. So what does that give us? Well, on the left it's 0. Then we get x squared. Now 240 minus 80, so that's going to give us a 60x, and minus 4,000. All right, so 0 equals, well, 40 and 100 are easy ones, and 40 and 100 give us a difference of 60. So that's a nice way to look at this one. And so we have that, so we can set each of these terms equal to 0. So x equals a negative 100 and x equals 40. Well, our speed can't be negative, so x equals 40 miles per hour is the original speed going on the 100-mile route, and x plus 20 equals 60 miles per hour on the new route. So that's the old and that's the new. Okay. And so that's all the questions I'm going to kind of work here. And so hopefully that will help you on the homework assignments.